Today we're going to start chapter 12, section 1, and today we're going to learn about sample space and probability. So the first thing we're going to do is talk about some definitions. So the probability experiment is just the action or trial that will give you varying results. So for example, let's say your probability experiment is flipping a coin. The outcomes or the results would be landing on a head or landing on a tail. When you roll a number cube or a dice, those outcomes would be, for example, 1, 2, 3, 4, 5, or 6. So whenever they refer to rolling a die, or sometimes they're going to use the words, they're going to say it's a number cube, know that that's just your regular dice with 6 sides. If they put a specific number in front, let's say you're rolling a 10-sided number cube, they will tell you. But if they just put the words number cube, they're talking about a regular die or a dice. That's plural. And the outcomes on that are the numbers 1, 2, 3, 4, 5, and 6. When you flip a coin, those outcomes are heads or tails. When the definition of an event is an outcome or a collection of outcomes, so for example, rolling a die and getting an even number, or rolling a die and having it land on the number 6, that is an event. The sample space is the set of all possible outcomes. So again, when you flip the coin, your sample space would be heads and tails. When you roll the number cube or the die, this would be, its sample space would be the numbers 1, 2, 3, 4, 5, and 6. So the sample space is just a list of all the possible outcomes. So for this one, here's our example. It says you flip a coin twice. How many possible outcomes are in the sample space? So in order to find the total number of outcomes, you're going to take each event and you're going to multiply the number of outcomes. So when you flip a coin, 2 outcomes, but I'm flipping it twice. So coin number 1 has 2 outcomes. Coin number 2, still the same, 2 outcomes. And you're going to multiply the number of outcomes. So in total, if I make an organized list, I should be able to find 4 outcomes. Now, in middle school, they probably made you do a tree diagram. So for example, and let me do the work down here. So this is example 1A. So if I flip heads, so first coin, so coin number 1, I know that when I flip it, I can either get heads or tails. These are my outcomes. Then when I flip coin number 2, I can also get heads or tails. And then I also have to put it here as well. So then now to list all of our outcomes in our sample space, I followed the branches of my tree diagram. So for example, I first would get a head, and then on the second coin, I get a head. Now I'm just going to abbreviate head with an H, so I can get a head and a head as my first outcome. Then if I follow the branch this way, getting a head on the first roll, and then getting a tail on the second roll, or the second flip. So this would be a head and a tail. And then let's say I flipped it and I got tails first, and then head second. So my next outcome would be a tail and then a head. And then if I did it again, tail, and then also getting, tail, and then getting the head. Or tail, sorry. Tail, tail. So these are my 4 outcomes. Head, 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 tail, head, tail, tail. 2 different coins. So you're flipping it and you're writing it down. So technically these two are different. This is coming up on slides later on. Let's say they said, what is the probability of getting a tail on the first flip and a head on the second flip? So you're going to look at your sample space and you're going to see that getting a tail first and a head second only occurs one time. So you would put that 1 over the total number in your sample space. And this is how we're going to be doing probability moving forward. Now, for the next one, let's go ahead and figure out how many possible outcomes. Now, in the homework tonight, they're going to give you a question like this, and they're going to say, list the total number of outcomes. Remember, you take the outcomes and multiply them. So here I'm rolling a coin. So this is part B. There's 2 outcomes. And then the number cube has 6 outcomes. So we multiply. So it has a total of 12 outcomes in my sample space. And now I need to list them. Let's say I was flipping the coin twice. Then I would have to do 2 times 2 and then times 6. So again, you're multiplying the outcomes. So let's go ahead and do our sample space now. Let's list everything. So on my coin that I'm doing first, remember you can get heads or tail. And then for the number cube, under here, remember you can either roll a 1, a 2, a 3, a 4, a 5, or a 6. So again, you would follow the branches. So you could either roll ahead or flip ahead and get roll a 1 or roll a 2, a 3, a 4, a 5, or a 6. We're going to do exactly the same thing. Let's say when we flip that coin, instead of landing it on the head, it landed on the tail. But then the same thing's going to happen when we roll that number cube. It could either land on a 1, a 2, a 3, a 4, a 5, or a 6. So it could either be a tail with a 1, 2, 3, 4, 5, and 6. Notice there are a total of 12 outcomes, and this is my sample space. So the sample space is a list of all the combinations. In order to answer the questions, when you get to the probability questions, you will need to list out the sample space in order to answer the questions. Let's go ahead and talk about the probability of an event. So the probability of an event, or the chance or likelihood that an event will occur, is always going to be a number between 0 and 1. Now it could also be between 0% and 100%, because probability can be written as a fraction, decimal, or percent. The notation that they're going to use is a capital P and then the event you're doing, whether they're just describing it as event A, or let's say they say you're flipping a coin and they want you to find the probability of heads. So they will tell you what the event is. They'll describe it somewhere. So when an event is impossible, it's not going to happen, that probability would be 0 or 0%. If it's sort of likely, that could be 0.25 or 25%, or as a fraction, 1/4. Equally likely, 50-50, so 0.5, 50%, or 1/2. Now your probabilities are not always going to be in these quarters. They're going to be other numbers. But just to show you on a scale where it might happen or might not. And then likely to happen, 0.75, 75%, or 3/4. And then certain would be 100%. It's a sure thing. Now, in the homework, they're going to either ask you to write your answer as a fraction, decimal, or a percent. Some of the questions are going to say, round it to the nearest whole percent. So you're going to round it to a whole number. You just need to read the instructions on how they want you to enter your answers. Now you are using a calculator because we are doing geometric probability. So you will be doing area of circles and we will need our pi button. However, you should understand how to convert a fraction to a decimal or a fraction to a percent. And even if you're using a calculator, you need to know that you divide it. So let's take the fraction here, 3/4. Let's say I want you to turn this into a decimal. So let's say you put it in the favorable over the total and you got that fraction and it says enter your answer as a decimal. So what we would have to do here is divide. You put the numerator in the box, add a 0.0, and then do the division. 4 goes into 37 times. You brought the decimal point straight up. Subtract, bring down another 0, and then 4 goes into 25 times. And that's how you convert a fraction to a decimal. Once you convert it to a decimal, we really would multiply that decimal by 100 or just move the decimal point twice, and that's how it becomes a percent. Now, one other way that you can convert a fraction to a percent is do a proportion. Set it equal to x over 100. Then you don't have to worry about moving any decimal points. It'll go right into the percent you need. So, for example, if I cross multiply here, 4x is equal to 300, divide by 4, and 300 divided by 4, it doesn't make it a decimal, it goes right to the percent. So again, you're using your calculator, but understand how to convert a fraction to a percent and to a decimal. It should have been something you learned back in probably 4th or 5th grade. So let's go ahead now and do another example. Let's find the definition of theoretical probability first. Theoretical probability can be found when all outcomes are equally likely to occur. So for example, flipping the coin. When you flip a coin, it's equally likely that that coin will either land on heads or tails. So the theoretical probability for flipping a coin, the number of favorable outcomes goes in the numerator and the total number in the denominator. So in the case of the coin, we know that if we wanted to find the probability that the coin lands on heads, we know that on that coin there is one head out of a total number of outcomes, heads and tails, which is 2. And again, if they asked it for a decimal, we would divide that and make it 0.5 or 0.50. Or if it asks for the percent, move it 2 times, and it's 50%. Let's say we're rolling that number cube or that die, and it says, what's the probability that the dice, when you roll it, lands on the number 2? So again, favorable outcomes. We're going to look at my outcomes on the dice. It's either a 1, 2, 3, 4, 5, or a 6. And there's only one number 2 out of the 6 outcomes. So this would be the probability written as a fraction. To write it as a decimal, we would have to divide it. And as a decimal, 0.16 repeating. However, I'm not going to write my percent as 16.6 repeating. The way that they'll represent that is going to be 16 2/3%. But if it says round to the nearest whole percent, the answer would be 17. Now, the way that they get 6 repeating into 2/3, you can take your fraction, 1/6, and solve it as the proportion. We're not going to add a decimal point. We're going to write the answer as a mixed number. So for example, if I cross multiply here, 6 times x, 1 times 100, I get 6x equals 100. I'm dividing by 6. So what I'm doing in my division box is going to be 100 divided by 6. 6 goes into 10 once. Subtract, bring down the 0. 6 goes into 46 times. And then when I subtract, notice it starts to repeat. So then what you do is you take the whole number, the 16, you take this remainder and put it over your divisor. And then you get 16 and 4 6, which simplifies to 16 and 2/3. So if you ever have a repeating decimal, that's how they create the mixed number. All right, so here we go. It says you toss a coin and roll a number cube. What is the probability that the coin lands on heads and the number 5? So what we need to do is list out our sample space. I already did this on the previous slide. Remember, on our coin, we're either getting a head, and then when we roll the number cube, that head could go with a 1, a 2, a 3, a 4, a 5, or 6. And then the same thing with the tails. Tail with a 1, 2, 3, 4, 5, and 6. If you prefer the tree diagram, that way is usually easier because you can list the outcomes down a column and then make the branches. So now, notice if they ask you just to count how many outcomes there were, on my coin, remember there were 2. So I would do 2, and then the number cube has 6, so 12 outcomes. And that's what I just listed there. So that's my denominator. That's the total. And now I'm going to look at my sample space, and I'm going to see how many times I see an H with a 5. And notice there is only one occurrence of rolling ahead or flipping ahead and rolling a 5. So there's only one of those, so 1/12. Now, if it asks for the decimal, you divide that, 1 divided by 12, and you get 0.083 repeating. So as a percent, this would be 8 1/3%. But if it says round to the nearest whole percent, the answer would just be 8%. So again, you're reading how they want you to enter the answers. In order to answer these, you have to draw out the sample space. So when you're doing number 5 and number 10, you can either go to number 10, screenshot that dice sample space so you don't have to draw it out when you do number 5. All right, let's try part B. So here on this one, they want me to figure out what is the probability that I'm going to choose a t-shirt that has a gold emblem. Now, when you're given all this information in a table, we need to get the total amount. So if I add up this first column here, these are all the t-shirts with the gold emblem. So I have a green t-shirt that can have a gold emblem. That's 10 of them. I have a red t-shirt with a gold emblem. That's 6 of them. So I have a total of 16 t-shirts with gold. Now I also have to get the total t-shirts including silver. So the silver total, add this column, the 8 plus 6, and that's going to give me 14. So I have a total of 16 plus 14. I have a total of 30 t-shirts. I now want to find the probability of gold. So what I'm shooting for, my favorable outcome, is the total number of gold t-shirts I have, which was 16 over the total. And then always reduce your fractions, 8 over 15. So if it asks you to enter the answer as a fraction, we're done. If it says enter it as a decimal, divide. 0.53 repeating. As a percent, 53 1/3%. Rounded to the nearest whole percent would be 53%. And again, if they want the mixed number, set it up as the proportion. Do 8 over 15 and set it equal to x over 100. And that's how you could get the precise percent amount. All right, so when we refer to a complement of an event, what we're going to be doing is the event itself and its complement always need to add up to be either 100%, or if it's given to you as a fraction or as a decimal, it has to equal 1. So in order to find the complement of an event, and the complement is written as the probability of event A, but the complement has a bar on top. And if they give you the probability of the event, like this one, to find the complement's probability, you're going to subtract 1 minus that decimal. So 1.00 minus 0.45, and I get 0.55. And that would be the complement probability. Because again, together, when you add the two probabilities, they need to add up to be 1 or equal to 100%. Classic example would be when we talk about the weather. Let's say I told you today the chance of rain, or the probability of rain, is 30%. The complement of raining would be not raining, and you would do 100 minus 30, and not raining would be 70. So again, the two probabilities need to add up to be 100% or add up to be 1. Asked to find a geometric probability, what we're going to need to know is our basic area formulas. So for example, on this dartboard, what we would have to do is, let's say they wanted to know what's the probability of hitting that red circle in the middle. We would do the area of that circle and put it over the whole square dartboard. Because again, it's going to be the favorable area, or what you're shooting for, over the total area. Now this one's a little bit more complicated because it's not just asking me what's the probability of hitting the red section. It's actually asking me what is going to be more likely to hit, the red or the blue. So either 10 points or 0 points. So actually I have to calculate the area of the red, put it over the total, area of the blue, and put it over the total. So if you notice here, notice this, each one of these radii of the circle, each piece of it. So for the red circle, notice the arrow that's pointing here. This radius has a length of 3. And then this little segment would also be 3. And then this one is also 3. So if I do 3, let's see, 3, 3, 3. So a 3 here, a 3 here, and a 3 here. The radius of the big circle is going to be 9. So if from here to here is 9, then I also know from here to here is 9. So this tells me the length of the side of my square is going to be 18. So the square, the whole dartboard, is going to be 18 times 18. So let's go ahead and do each probability. So let's do the probability of 10 points first. So probability of 10 points. That's that inner pinkish red circle. So in order to find that probability, I'm going to find the area of the red circle, or that smallest circle, and I'm going to put it over the area of the entire board, which is a square. So the square is just 18 times 18, or 18 squared. And then the inner circle, that red circle, pi r squared, and the radius is 3. So this inner circle is 9 pi. 18 times 18 is 324. And then I can reduce that, and it's going to reduce the pi over 36, because I can divide them both by 9. So the 9 pi over 324 reduces to pi over 36. I'm going to divide this because when I do the bottom one, it'll be easier to compare two decimals. So this is going to be the probability that you would get 10 points when you throw a dart at that dartboard. and the decimal is 0.0872664626. Now I have to do the blue section. Now the blue section's a little bit more complicated. So the probability of 0 points, which is the blue section on the dartboard, in order to find that, I'm going to be finding the area outside the largest circle, or the blue part. So all that outer blue part. And then I'm going to put it again over the area of the entire board. So my entire board is still the same. It's 18 times 18. Now the area outside the largest circle, I'm going to take this 18 times 18, the 324, and then I have to subtract the circle. And notice my circle had a radius of 9. So for the inner circle, which is, let me just show, it's this whole circle here that I'm going to subtract out that area. So it's going to be pi times 9 squared. So then that's going to end up giving me 324 minus 81 pi. So now I'm going to go ahead and do 81 times pi. So 324 minus 81 times pi is 254.4690049. And then I have to divide that by 324. So once I do the subtraction, 69.5309951. Divide that by 324. And the decimal that I'm going to compare it is 0.214601837. So I'm comparing this number with this number to see which one is the bigger number, and that would be the more likely probability. So I'm comparing the 0.087. Let me just round it to the 7.3, and then take this one and just put the 0.2146. And you can already see that the 0.2 is the bigger number. This one's bigger than this one. So you're more likely to get 0 points than the 10 points. So you're more likely because it's got the bigger probability. Okay, so for experimental probability, this is different from theoretical. Theoretical probability is what you think should happen. Experimental probability is based on repeated trials of an experiment. So it's something that's already been done, and they'll probably give you the results. So for example, let's say you flipped a coin 10 times and then recorded the results. When you flip a coin 10 times theoretically, you would think that half of the time you would get heads, half of the time you would get tails. But when you actually do an experiment, let's say you flip it 10 times and you record the results. So let's say I flipped it 10 times, and let's say it landed on heads 3 times and then tails 7 times out of the 10. Then if it asked me to find the probability of heads experimentally, there would have been 3 out of the 10, or 30%. But theoretically, it should have been half. So that's the difference when you're doing an experiment. You just keep repeating. The trials is the number of times you do the experiment. So in this case, the trials were flipping the coin, and I wanted to do it 10 times. The success is going to be how many times, or your favorable outcomes you were looking for. So here it says each section of the spinner shown has the same area. The spinner was spun 20 times. So what was nice is they gave us the total already. We're not going to need to add it up. However, if they didn't tell us the total, then I would have had to have added all these numbers to get my total. So then here it shows the results of when you spun the spinner, that red came up 5 times, green 9, blue 3, and yellow 3. So let's go ahead and calculate the probability experimentally. Then I'm going to go back and do the theoretical. So for the red, once I do my experimental, it came up 5 times, so 5 over 20. And then I simplify, and the experimental probability of red is 1/4. Then when I do the green, green came up 9 times out of 20. I can't simplify it, so that one's done. And then the blue came up 3 times out of 20. That one's can't be simplified. And then lastly, yellow, let me just write it in black so it shows up, 3 over 20. So that's how I would have calculated the experimental probability. But now let's go back and do the theoretical. So this is all the results of experimental. Now I'm going to write the theoretical probability. So each one is going to be the same. So each section is equally spaced out, has the same area. So the theoretical probability of red, there is 1 red section out of the 4. And look, I already found my answer. So the color where the experimental probability for this experiment is the same as the theoretical would be red, because green would still be 1/4, so would blue, because there's 1 blue section out of the 4, and then the yellow would also be 1/4. They all have the same probability for theoretically, but experimentally, it didn't happen. Now, one thing that could affect your experiment is, let's say your spinner was on a tilted table, and let's say it was tilted more towards the green section of the spinner, and maybe that's why green came up more often. Or, maybe there was something on there that slowed it down. So there's different things in the environment that could affect your experimental probability. So that's why it doesn't come out to be what you think should happen.